I hope you guys can see my screen.
I
Not
see it
yet,
as
Ash.
Just a minute. So can you guys see it now? Sorry.
We still see the same black screen that says you started screen sharing, but it says double click to enter full screen mode for us, I guess. So it's just a black screen. If you prefer to debug your system, I can go ahead and make a very short oral introduction about the bigger topic about the complexity metric. Should we do that?
Let me give it a try for one last time.
Okay, okay. Third time is a charm.
hurrah.
Yes.
Much.
Third time is a charm.
Okay, I think. So you guys can see my screen. I'm not sure again.
We could, and then as soon as you asked, something changed and we couldn't see your screen anymore.
So you guys can see it now, right?
Nope, it's gone back to the black.
I'm sorry.
So,
did
you go to,
is not the charm.
Yeah.
go to mode?
Krishna, it's okay. Let's not do it under the pressure of time. So let me just make a short introduction and you figure out all the system settings. How about that, Krishna? Okay.
Okay.
Okay. So again, first of all, apologies for not joining the introduction today. For those who don't know me, I'm Yannis Katsavounidis. I'm part of the video infrastructure team at Meta. I have been working on video quality and video codecs and an overall system optimization for the past 10 plus years. And together with Margaret and Werner and Cosmin, but I don't know at this point who is more active among us, probably Margaret. We have been, working on a number of no reference metric topics. And the specific topic that I would like to describe to the group and of course hear opinions and give you a little bit of a plan of action is this regarding the so-called complexity metric, okay? So let me refresh everybody's memory what we hope to do here. It all starts with SITI, and we all know it very well. It's old, it's tested, but everybody's blaming it for not really providing very useful information when it comes to compression of a certain source. So if you try to correlate SITI about how many bytes you would like to spend in order to achieve a certain quality, or say, is this video more complex than another video? It's not something that really works very well. So starting with that, we said, well, how about if we target specifically this application, right? So how about we want to design a complexity metric that will tell us a number, and that number can be a proxy of how many bits or how much actual compression you can achieve from a certain video. We debated about whether this should be on a single quality or multiple qualities, on whether it should be the absolute number or whether it should be the slope. But the last time that we had a meeting on this that I at least remember is that we agreed to do it in a simple way. If you provide the video, you want to extract a number that we will try to approximate the number of bits that it would take for that video to be encoded at quality, VMAF quality of 80. Okay, so, and of course, one can argue that one can actually do the encoding itself, and with a codec such as X264, this is actually very efficient and very fast. So it goes without saying that when we talk about a complexity metric, there is a sort of constraint on how much complexity you want to spend on it. Now, the discussion moved forward, and I undertook some preliminary study where the video set, for those who don't remember, video set is an expansive set of multiple AVC encodings that were produced as part of the GNT testing that happened in 2017. I hope my memory doesn't fail me. And in order to do that, all QPs were produced for a great number of videos, and therefore we decided to go back and reanalyze all these and see which exact QP for every video actually achieved that VMAF of 80, and use that sort of as a testing and training and essentially a data set that researchers can use to maybe develop their own method. And after I did maybe 5 or 6 of them, then I gave up, and I have no other update to give to the group other than the plan of action still remains that produce that data set, offer it to researchers, and let them propose different methods. And hopefully when Krishna presents after me, he will present something along those lines. But I want to give you a few other independent activities. When I say independent, they happen outside of VQEG, but I consider this to be a great community, right? Doesn't really need to be done. Good things don't really need to be done at a predetermined call for NOM, for example. We have been working with other researchers, and the idea here is to make that actually jumpstart it and invite more people, make it a grand challenge in one of the major signal processing, image processing, video processing conferences. And by setting the rules, right, again, we're going to predict the quality of, say, 80, VMAF 80. We're going to do it efficiently. Here is a training set. And of course, an unknown secret, as it always happens with these grand challenges, validation and actual performance testing. We hope to obtain many, many more proposals. First of all, from the people that are in this call, right? So many people in VQEG, I think, are both very eager, very capable, and willing to contribute, but from the broader activity out there. I'm stopping here, first of all, if anybody has any questions.
Hi, sorry, I cannot find the raising hand button, so I just jump in. So I understand you wanted to have one number only, and not like 2 or 3. And is it like you know that this one, like that the sequences doesn't change drastically? Like the question is how probable is that the sequences got the same bitrate and with the quality VMAF 80, but very different with 60 or 40, VMAF 60, VMAF 40, and VMAF 90, for example. Yeah. So you kind of know it that it's not really the case, or you hope it, or you just are limited to one number and you cannot do anything else.
Yeah, I'll try to recollect, because there was an expansive and extensive discussion along this, and of course we decided to go it one way. It doesn't mean that's the best way, right? We just chose one thing. But there was, of course, it goes without saying that whatever complex, and again, let's for the moment define complexity equals bits to achieve a certain quality with a certain coding standard, such as good old AVC. We know that in order to achieve a quality of 60, it would take less bits, or at least should be straightforward. So the only question will be, how much less, right? And that already puts us into the business of slope. Because if you have 2 points, then the slope that you get between the two could be arguably a better, or maybe not as good as the single point. So there are two schools of thought. At the end of the day, what we're talking about is an RD curve, right? The RD curve is not going to be a line, it's not going to be a parabola, it's going to have its own characteristics. If you have a way to parameterize the VMAF value, so if you say complexity metric, parenthesis, VMAF 85, that would be, in my opinion, the next evolution to really map the entire curve, and that should be sort of a North Star, right? But 80 being a number that is for multiple studies, and I hope the previous presentation that I quote from Ali convinced many people, 80 is a very, I can say, applicable and good number to use for many applications, right? Because one can argue, oh, 95, too high, it goes into perceptual losses. 50, 40, annoying, right? I don't want to be watching it. So at the end of the day, you want to capture at least a midpoint, a calibration point. So in summary, we considered other alternatives, the full RD, just a line. But at the end of the day, we opted to go for that single point as a starting point.
Thank you.
Is there any more questions? I saw Nabajit pointing to a paper. Now, do you want to talk about it?
No, that's just the video set paper that you mentioned. I just shared.
Appreciate it, Nabajit.
Mm.
I didn't have a chance to look at it. Okay. With that, I hear no other comments, which means people are like it, don't like it. It's okay. They are going to work on it if that, grand challenge comes out. Any people want to have any? It's okay. If there are no more comments, I can just stop and pass it on to Krishna.
Hello, Yannick.
Yeah,
Oh,
I see
sorry.
Nabajit, go ahead.
Yeah, I have a question. I think initially when we started this discussion, so it didn't come to my mind. So for example, the SITI, right? So the initial idea behind this complexity metric came from the initial discussions we have had about SITI not being that accurate and all, right? And that metric is usually what we know of is to select source reference sequences, right? So that was the main goal behind that. And by that, what we mean is basically the videos are of either very high quality or lossless, right? Almost lossless perceptually. And then when we moved into the actual discussions, we started considering probably UGC content and both professionally generated content. And then comes the question of now codec introduced artifacts, right? So is the idea still to consider that, or is that, I mean, because how do we see the effect of codec being taken into account when we come up with a complexity metric, right? With so many different families of codecs being there out there now.
Yeah. I have my own thoughts, but we can open it up for a broader discussion. Just a couple of quick comments, right? SITI has its own values. So make no mistake, this is not a substitute for SITI. For example, when you want to capture diversity, right, you have a database of, a billion videos, a million videos, and you want to pick representative content, not necessarily for compression, by the way, because compression is not the only thing that people do, right? We all understand that. But the one thing you do want to capture for the, and I don't want to speak for Matthias, but my understanding is that, MPEG does routinely a very good selection of content, for example, to use in standardization, right? So you would like to have a metric that says, oh, you know what? I believe that if I take those billion videos and I start compressing them, there is going to be the easy, the medium, the high, and I would like to pick, I don't know, a mix of them, or maybe from that category. That's really one of the potential usages of this new complexity metric, right? Not to substitute SITI, but more guide decisions when it comes to source selection, and then for people who design processing algorithms, right? Pre-processing, post-processing, they would like to test it again on a limited set and get some useful numbers. I would say that's where probably it's going to be one more weapon. But again, if others have more ideas, please chime in. Otherwise, I see Ali raising his hand.
Thank you. I had a quick question. What would be the the use case that we target the videos on this if there is when this challenge happens. So will we rely on pristine content, more focused on, let's say, online video streaming services or movies or this kind of applications, or are we talking about user-generated content as well?
And again, my personal thoughts, based on not just what you presented, but what many people know very well, right? VMAF is a DMOS, basically proxy, right? So there is this 80 would not mean 80 for a, noisy content. So my thinking is that this would apply originally on pristine content. And fortunately, the video set is made of pristine content, as you know, right? So at least we start off with a data set that is coming from the same cohort. But eventually later, if we would like to predict not VMAF, but subjective score 80, now that's a real question, right? That would be a different problem. And I see Margaret raising her hand.
I have two things. One is, I think that question of whether to include or exclude user-generated content needs more discussion. I ran user-generated content through VMAF, and as long as you accept that the impairments from the camera are going to be completely ignored by VMAF, then it really worked very well. I was impressed with its assessment of the compression artifact impairments added to an original that had some problems. My other thought is that we should establish an online meeting, something like a month from now, and continue this discussion there, since there seems to be interest in further discussion on this. I'm certainly very interested.
Thank you, Margaret, and I'm very happy to hear that. And I would say also my experience is that unless there are severe artifacts in the source, think someone who took a 1080p source and they first downgraded it to 540p or even less, right? That's where, objectively, think of it this way: if the source was never rated more than a 3, how could you ever predict an 80, which would map more like a 4, right? So that 4 really is more a DMOS, as I said before. But yeah, I agree. My experience is that with mild source degradations that are independent of compression, VMAF works very well. And I will double down, and I'll take as much blame as people want to give me for not really being very diligent lately on driving this activity. But I do consider it to be a very important activity that will be embraced by not just the compression people, but for the whole research community in this field. Thank you, Margaret. And I see Francois.
Just one response back to that. I would argue that even fairly severe camera artifacts are okay, as long as it isn't resolution or frame rate. Thank you. And Francois?
Thanks, Margaret.
Something that I'd like to bring in, Margaret, I think we briefly talked about it, is on those user-generated content and short form video, there is now a new dimension beyond video, which is the responsiveness of the application, stalls, buffering, and delay. And in some cases, we're finding research now that are indicating that they're becoming a bit more annoying than video quality itself. So I don't want to create a controversy here at the VQEG, but it might be interesting to, at some point, look at a composite metric that will include video, but other factors. So I'm just bringing this up here as a suggestion, but I'm not sure we want to do that, but I'm just saying it's becoming important.
Thank you, Francois. Anyone else on this short discussion? And I think the key takeaways maybe to be noted would be that there is enough interest from a number of people for this activity to go live again. And maybe your idea, Margaret, of setting up a call in a month from now to really resume wherever we were before would be a good next step. And again, the community will be among the first to find out when we decide to move forward and establish this grand challenge, the rules for the data sets, and the dates, etc.
Okay, if it would work for you, Yanis, I suggest we target January 22nd at the time we've been meeting.
Let me get back to you online. January 22nd is probably a very special day, but I will, let's not commit today if possible.
Okay, then pick a day and get back to me. Okay, so thank you. Interesting discussion. And let's move to
Krishna?
Krishna.
Yes.
And let's try again. Last time we could see your slides when you were in the not the presentation mode, sharing your desktop. Oh, hey, there they are. Wonderful.
Excellent, excellent.
Fabulous.
Yes.
Okay.
Okay, I'll start. Hello, everyone. My name is Krishna Srekar. I'm a second-year PhD student in Dr. Alan Bovik's lab at UT Austin. I'm collaborating with Meta Platforms in optimizing video delivery. My work is related to constructing bitrate ladders using popular full reference quality assessment technique, Visual Information Fidelity, or VMAF. We submitted a previous version of this work in PCS 2024. This presentation contained the same work under slightly different conditions with better comparisons. So here is the table of contents. I'll give a brief introduction or overview of the video delivery pipeline, followed by some industry standards. Next, I'll describe popular works in this field, followed by the details related to our experiments and approach. And finally, we'll move on to other results and the future work. The following block diagram describes the general architecture of the video delivery. A video, which is either compressed or uncompressed, is downsampled to a resolution R1 and is encoded using an encoder based on various settings like bitrate, quantization parameters, CRF values, etc. And it is transmitted. After transmission, the video is decoded and upsampled to the resolution of the viewport R2 and is displayed to the user. We can either perform quality assessment between the original resolution and the compressed resolution R1 or between the original resolution and the upscale resolution R2. Over the past few years, fixed bitrate ladder has become the conventional approach for adaptive video streaming conditions. Even though one size fits for all approach is optimized for all most of the important video characteristics, it does not guarantee an optimal bitrate ladder for a given video. Subtitle video encoding introduced by Netflix engineers provides an optimal bitrate ladder for each video content, but the disadvantage of this approach is its computational requirements. Each video needs to be compressed and quality estimated enormous number of times in order to create an optimal bitrate ladder for each video. The table shows some previous works describing the techniques used to construct subtitle bitrate ladders. Most popular works include predicting crossover points between rate quality curves and predicting quality or optimal resolution for a video content at a particular bitrate. Most of the works use features extracted from uncompressed videos to construct a per-title bitrate ladder. Crossover points are defined as intersection points between rate quality curves between two resolutions, where switching happens from low resolution to higher resolution. They are defined as either a pair of QPs, that is one for each resolution, or as a crossover bitrate. These crossover points are predicted using low-level features like GLCM, temporal coherence, normalized cross correlation, etc., which are extracted from uncompressed videos, and these are later on used to construct bitrate ladders. DCT-based energy features are introduced by authors in 1 and 2 as a replacement for conventional features like SI and DI. These features are used in construction of bitrate ladder by either modeling quality of compressed videos as a linear regression using the custom feature as shown in this figure, or directly predicting the optimal resolution based on quality predictions. For our experiments, we are considering BVT100 4K dataset created by Dr. David Arbul's lab. The dataset consists of 100 uncompressed videos of Ultra HD resolution, each having 60 FPS, 10 bits per sample, and 64 frames. So essentially, with 60 FPS, it's a 1.07 seconds video. We divided the dataset into 70, 10, 20 non-overlapping splits of training, validation, and testing sets. We made sure that there is no overlap in video titles to make sure that models see completely new content during testing. We compressed the videos using LIB265 codec with encoder preset set to medium. We considered 7 resolutions from 2160p to 360p, maintaining a similar aspect ratio. We considered constant quality encoding while compressing the videos by varying CRF values from 16 to 35 and then to 40 with a skip of 2. We estimated VMAF value for each of the compressed video, assuming that videos are viewed on a 4K screen. In our experiments, we consider rate quality points with a minimum CRF value of 10 and a maximum CRF value of 95. Our objective is to predict the quality of compressed videos without performing any compression or quality estimation between compressed videos using natural scene statistics, which are popularly used in full reference quality assessment techniques like VMAF, WIF, BRISC, etc. In our work, we present multiple WIF feature sets extracted from different scales and subbands of a video to tackle the problem of bitrate ladder construction. We utilize spatial WIF features obtained from frame-based WIF, the mean absolute luminance differences computed by BMAF, and the same WIF features computed on full frame differences. The advantages of these feature sets is that these features can be calculated using the existing VMAF pipeline. We concatenated our features with meta information like bitrate, scale width, and scale height of the compressed videos, and trained regression models to predict VMAF of compressed videos. We also designed an approach where we use an ensemble of WIF features and low-level features to predict quality. The table shows the list of low-level features used in our experiments. Most of these features are used in previous works, generally in tasks involving rate distortion curves and bitrate data construction. We compare the performance against Apple's fixed bitrate ladder and reference bitrate ladder constructed using exhaustive encoding. We also compare the performance again with two other approaches, that is predicting quality using crossover bitrates, constructing a bitrate ladder using crossover bitrates, and predicting quality using low-level features. When predicting crossover bitrates using low-level features, we use recursive feature elimination to decrease the number of to select most optimal number of features, so that we can predict recursively and auto-regressively predict crossover bitrates between multiple resolutions. And we are using all 93 features for predicting quality, along with the custom features based on bitrate and DCT based energy features introduced by Mr. Vignesh and Hadi in their works. For a bigger sample size, we evaluated our models on both validation and test data sets, which are not used in training at all. We can observe that our models, when trained on these features, show significant gains against fixed and reference bitrate ladders, and performance is very close to reference bitrate ladders. When an ensemble of low-level features and WIF features are trained together, we can see that the performance has improved when the models are either trained on low-level features or WIF-based features. Our best performing approach, which is low-level features and which is trained on low-level features and feature set number 3 from WIF, performed very close to bitrate data constructed using crossover bitrates, and its performance is very close to reference bitrate ladder. Here are some examples from test data set. Pareto reference constructed using our best approach, reference bitrate ladder, and fixed bitrate ladder. We can see that the blue curve shows the Pareto reference constructed from our approach. The green one shows the reference bitrate ladder, and the orange one shows the fixed bitrate ladder. We can see that the blue and the green curves, which are essentially the best approach, and our best approach and reference bitrate ladder are very close to each other. Here are the directions that we are considering in our future works. Consider a model trained only on metadata, like bitrate and resolutions, without any video content-based information. The bitrate ladder constructed by such a model, when we try to predict qualities, would be the best statistical fit that the model can achieve based on the training dataset. When this model is trained without any regularization, the bitrate ladder constructed has shown good BD metrics performance, but the quality predictions made by the model are non-monotonic. Under regularization, even though the quality predictions are monotonic, the BD rate metrics are heavily affected. So it can be understood that evaluation based only on BD metrics has certain vulnerability to it. We're working on ways to resolve this issue. Since machine learning models are associated with error, the bitrate ladder constructed or predicted might not be monotonic. For example, this one. We are also working ways to improve the bitrate ladder correction procedure. This also applies to correcting the reference bitrate ladder constructed using exhaustive encoding to have a monotonical change in resolutions with respect to bitrate. A simple solution would be to traverse the bitrate ladder from top to bottom, imposing the condition that the resolution at a bitrate should be less than or equal to the resolution at the next higher bitrate. We're also working on different ways to improve the correction procedure. Thanks to Meta Platforms for funding our research, and thanks to everyone. Thank you.
Thank you. So Very nice. Do we have any questions? I see Napajit.
You are muted, Nabajit.
Sorry, thank you. Thanks a lot, Krishna. Can you go to the encoding part, the dataset part once? Yeah, so just a quick question. Are these all encoded in 10-bit or did you use 8-bit encoding here?
8-bit encoding.
Okay.
I mean, the original videos are 10 bits, but
Yeah.
I'm
No,
trying to
no.
estimate all the low-level features and everything. I converted them to 8 bits.
And is there is the original data set cropped to 64 frames, or is there a particular?
Yes, it is. Yes,
Okay.
it is cropped to 64 frames.
Okay. And do you have any idea of the complexity of the method that you are proposing? Is how complex are we talking about?
So I didn't exactly work on that area because comparing complexity between multiple metrics, multiple approaches would be difficult because of the programming languages that they are implemented in. For example, video complexity analyzer is implemented in C. So when we try to implement the same idea and the algorithm in Python, there'll be a different complexity essentially. And also when we try to compare the performance of the proposed approach with respect to exhaustive encoding, the problem with that would be VMAF uses multi-threading. VMAF 4K model essentially uses multi-threading to make sure the quality estimation runs faster. Similarly, FFP uses multi-threading. So there is no exact metric or exact way to evaluate or compare complexities between different metrics. All we can do is just time them using time module from Python and just get some numericals. So since there is no exact way of comparing comparing different algorithms or different approaches, I haven't exactly worked on that area.
Okay, but do you still know roughly how complex it is to? Can you go to your next slide? Probably. Yeah, this one, like how complex is to extract these features set that you have extracted here.
These features are essentially when we estimate VMAF, WIF is a part of VMAF, right? So these features are essentially calculated as part of VMAF. So the main advantage of approach is that there is no need to create or develop new modules to create new features or calculate new features. The existing VMAF pipeline with some tweaks or to get these features could be used to construct a bitrate ladder with sufficient BD rate savings.
And can you go to your BD rate savings table? Just
Yes.
You wrote here a BD VMAF in dB. Did you change the scale here of VMAF or?
No, I didn't change the scale here directly.
Okay.
I'll try to consider that. Thank you.
Okay, thank you. Thanks a lot.
Yeah,
Lucas?
I think it's my turn. Thank you. Yeah, on this slide, so you have BD. What is the reference ladder here? Is it based on VMAF or not?
Basically, dynamic optimizer. A bitrate ladder by encoding videos over a range of multiple CRF values, multiple resolutions, and constructing the optimal convex hull.
Okay, but the metric that is used in the DO is VMAF, right?
Yes.
And am I missing something or? So BD VMAF is basically when it's negative, it's worse than regular than the reference,
Yes.
right? Yeah.
Yes. When it's negative, it's worse. When it's positive, it's better. So
Gotcha.
when compared with fixed bitrate ladder or Apple's fixed bitrate ladder, the BD rate savings are good. We have good BD rate savings and better quality estimations. When compared to reference bitrate ladder, we are essentially losing bitrate and slightly losing quality too.
Yeah, just wanted to make sure, because I'm struggling to connect the previous slide that you showed where the features are listed to what is the feature set and low level features here.
These are,
because yeah,
I'm calling these low level features and my proposed features as WIF features, just to maintain enough distinction between them.
Yeah, so you have a bunch of low level features that you listed there, and you're adding some of the WIF features from libvmaf library to that list.
Yes.
And then you train on that.
Yes, if
yeah,
you only based on WIF features, this is the performance. And if you use an ensemble of those both the features and low level features, this is the performance.
Okay, understood. Thank you for explaining. Yeah, my concern would be same as Namajit. Is basically that now you are extending the feature pool, and your motivation here would be to be less complex than VMAF is. And VIF actually is the most complex part of VMAF. So that would be a little bit of a, yeah, like we need to find a way to actually do the comparison that you said is very difficult. Otherwise, it's very hard to say, like, is it even worth going this direction if it would be more complex than VMAF, right? Or what would be a good trade-off? What are actually necessary features there? So that would be maybe I would say the direction that I would go with to try to answer this question.
I would like to highlight one more point. So when we calculate VMAF between uncompressed video and a compressed video. When we try to construct a bitrate ladder, you essentially optimal bitrate ladder or convex cell, you essentially need to compress the uncompressed video multiple times and need to calculate the quality multiple times. The benefit of this approach or the WIF features that I'm proposing is that they're essentially only extracted from the original video or the uncompressed video. So essentially, you need to run VMAF or WIF only once. Unlike constructing a convex cell, where you need to run it multiple number of times, depending upon how accurate you want your convex cell to be, you essentially need to run your WIF or VMAF module only once to obtain these features.
Okay, thank you. That's the biggest selling point that I completely missed. So thank you.
Okay, any final questions? Yes, Hadi?
Yes, thank you very much for the nice presentation. So I was just wondering that these features that you are extracting are just from the uncompressed video, or you mentioned also from compressed video, right?
Every feature extracted is from the uncompressed video.
So you just extract once from one uncompressed video, original video?
Yes.
Okay, thank you.
Okay, and Nabajit?
It's just a follow-up question. Do you have a paper or an implementation of this already available, or?
So we just submitted it to PCS 2024.
Okay.
Today is submission deadline. I mean, we submitted it 20 days ago, but today is submission deadline. After that, I'll make my code available and everything.
Okay. Thank you and good luck.
After it on archive, so.
Okay. Thank you.
But it doesn't have this much detailed comparison because there is a four page limit to PCS and everything. We only submitted till here. So this one is an additional work that I did for this presentation.
Thank you.
Okay, thank you. Any more questions?
If I may chime in, because I saw Hadi. Hadi, would you like to elaborate a little bit? I'm not sure how much you captured of the. First of all, I want to thank Krishna. Of course, I know his work a little bit better than the rest of the group here, but thank you for the presentation. I think this is, again, the big elephant in the room will always be complexity. I said it in the beginning, right? And I keep saying it every time. Because especially with the evolution of faster and faster encoders, including hardware quality metrics, you start questioning how much is this going to buy us. But I think this is on the right path. And thank you for taking the time to present it to the group and hearing the feedback. Hadi, since I'm not sure how much you captured, I gave a brief overview of the ideas we discussed a number of times, but would you like to elaborate a little bit more? Is there, if you think it's premature, we can postpone it and announce it to the group later. But I already said that we are working on some kind of grand challenge.
Yes, I was actually in the meeting. Thank you very much for this presentation and bring this up. Actually, we had this idea that to have a grand challenge to improve this complexity metric. So as Johannes mentioned, we have SI and TI, but we were thinking that maybe new ideas can come and maybe researchers can contribute as a part of this grand challenge. So we were hoping that some of you will be interested in this grand challenge and we will get this feedback and then we can move forward. Just one point is that if we are going to consider, for example, ICIP, the deadline for our grand challenge would be the late December. and we need to announce the winners, I think, March. I don't know how much it would be visible for us, but just wanted to let you know about this deadlines that we should consider if we want to submit it to ICIP.
Thank you, Hadi. And Margaret, I think we wrapped up. I'm not sure how much we are on time or out of time, but thank you to all who have contributed in the past. Oh, I see Nabajit raising his hand.
Yeah,
Nabajit.
sorry, I didn't understood, Hadi. Yeah. Is the grant channel already accepted and published, and the deadline is in December, or is the proposal submission in December end?
To have this proposal. So, but we wanted to get feedback from VQEG that if there are people interested in contributing to this grant challenge. So if we want to submit this proposal, the deadline for us would be late December.
Okay.
The result of the proposal will come on 12 January. But the thing is that we need to announce the winner by 6th of March. So I think everybody will have around 2 months time to, or less actually, to contribute to this grant challenge.
Okay, okay, understood.
And if I want to add, at least again, very broad stroke, right? Our thinking is to include some kind of, as all grant challenges, precision of the method, right? We just saw some numbers, for example, from Krishna as a potential, contributor to this challenge, but also some proxy of complexity. So there would be a need for people to contribute either code that we can run or actual runtimes or some kind that will also allow us to cross-platform, cross-language, and cross-architecture translate complexity from one to the other. So for those who are thinking about preparing a contribution, and we invite everyone, obviously, in this group, you do need to have some kind of reproducible and measurable complexity figure, right? Okay, anyways, that's about it. Margaret, back to you.
So for that question, could you make up like one slide to show? And let's devote maybe like 5 minutes just to have you say that again with people looking at a slide and give people a chance to say, yeah, I'm interested.
Hadi, I volunteered you before, right? And I'm not sure if you are up to maybe share the preview of what we are debating, right? That Google Docs that you prepared. Otherwise, I can just put some high-level thoughts. I'm not sure if you prefer not to show the actual content, so you don't give an unfair advantage to what we are planning to finalize. So again, I want to understand we have the right timing here. Hadi, it's totally up to you if you want to share anything in a slide or two to give this group a little bit better understanding.
I think it would be better that if it is up to you, because I prefer your feedback on this. So any decision that you make is okay for me.
Yeah, I think then I will draft something that will not go to the exact details, the parameters, the data set, so it doesn't give, but just the two major axes, precision, right, of prediction and compression efficiency. Sorry, computational efficiency would be the two key metrics that this grant challenge will try to address simultaneously.
Exactly.
And timeline would be another good point to add, so people understand the timeline.
I will sync up with Hadin. When we have the next norm call this week?
So we don't have any norm calls scheduled, and this is the end of the time for norm. So just pick when you'd like to discuss this, Tuesday, Wednesday, or Thursday at the end of the day. Put it on the presentation, add it to one of those.
I'll work with Hadi and have something, again, probably will be less than 5 minutes now that we presented the higher level concept.
Yeah, just if you could send me an email, pick which day of those 3 days you think would be best for you to discuss. I think, it might work well after SAM by topic, or, there's a nice mix on Thursday that we're ending with. So whatever you think is most appropriate fits your schedule.
Right. We'll do that.
Okay.
And hopefully I'll be less jet lagged by then, so I'll be a little bit more coherent. Yeah.
Sounds good. Lucian?
Well, I just want to suggest that since not everyone connects all the time, then I agree that this is really in line with SAM, and we can easily fit it there, and then you can repeat it again probably if it's 5 minutes, it won't hurt anyone, and it can reach more people. Yeah.
You know, Lucian, I love Sam, so how can I say no?
Okay, that sounds good. We will plan on discussing this again at the end of the day tomorrow. Lucas?
Sorry, this was just me.
Lucas, I see your
Silly
hand.
clapping.
Okay. Well, thank
Thank
you,
you, Lucas.
everyone.
Thank you.
That is the end of our day. We are almost exactly on time, so hurrah. And we will see you again tomorrow, starting at the same time we did today. Any last thoughts, Shell, before we close?
No, I mean, I think you captured it all. We end now and we start the same time tomorrow, and I will stop the recording now.